Welcome back to the deep dive.
Hmm.
Today we are tackling a subject that, honestly, it can cause some undue stress in even the most seasoned flight deck.
Oh, yeah.
Holding patterns, and specifically how the Airbus A320 handles them.
Right.
The A320's Flight Management Guidance System, the FMGS, it's an absolute powerhouse. It can fly circles beautifully, no question.
Flawlessly.
But it demands one thing: a pilot who really, truly understands the internal logic it's following.
That's the key right there.
So our mission today is to uncover that specific logic. We want to make sure you walk away understanding the three fundamental categories, the critical traps, especially that famous VDEV trap.
Mm-hmm.
And most importantly, the specific pilot actions needed for each. Because when ATC throws a surprise delay at you, you need confidence, not confusion.
That's exactly right. You know, in the air, your cognitive effort is your most valuable resource.
Of course.
And mastering this FMGS logic is the best way to minimize that load, especially when things get busy.
Okay, let's unpack this. So let's start with the basics. Because in the Airbus world, not all holds are created equal.
Not at all.
We've got three distinct categories. Let's call them three different flavors of holds. And knowing which one you're flying dictates everything.
It does. We call them HF, HA, and HM.
And you have to get this right, because two of them are designed to be entirely hands-off once they start.
But the third one, the one ATC loves to give you, it requires your constant attention and a very specific command to leave.
Right. If you mix them up, you could blow past a waypoint or just, well, fly in circles forever.
Exactly.
So our first flavor is the hold to fix, or HF. Think of this as a very specific procedural hold.
Almost like a procedure turn that's built right into a star or a transition.
Its purpose is course reversals, maybe some alignment maneuvers.
And you'll see them embedded right in the navigation database. The critical behavior here, though, is that it's a flyby procedure.
Flyby, so it does it once.
Exactly once. The aircraft flies the pattern, gets back to the fix, and then automatically exits and carries on to the next waypoint.
So if you see an HF on your flight plan, your action is simple.
0, no termination required. It's hard-coded, and importantly, you can't create one yourself. It's part of the route design.
Okay, that's HF. Next up, we have the hold to altitude, the HA.
Ah, the HA. This is your classic climb and hold maneuver.
You see these on departures, on SIDs.
Right, all the time. The procedure needs the aircraft to spiral up to a safe altitude before it goes on course. So the airplane will just keep circling until it captures that specific altitude.
And once it hits that altitude.
Only then will it automatically exit at the fix and continue on.
So again, both HF and HA are self-terminating. They're procedural tools, not really for traffic management.
Absolutely. They're just route components.
Which brings us to the big one, the one the controller throws at you, often when you least expect it.
The hold with manual termination. Okay.
This is your standard ATC holding pattern. For traffic, for weather, maybe you just need a few minutes to run a checklist.
And what's fascinating here is the operational risk wrapped up in this distinction.
How so?
Well, HF and HA, they stop on their own, but the HM, its default behavior is to fly indefinitely. It is truly designed to just sit there and wait.
So the pilot action is non-negotiable.
You must explicitly command the exit. This is the one you're interacting with the most and where you need to customize things.
Right. Speaking of customization, let's talk about how we actually build an HM when ATC gives you an instruction.
It could be hold at present position or something more complex.
Hold at waypoint delta, inbound 090, right turns, 4-mile legs.
So you open up the MCDU holdee page. Two things can happen.
If that hold is already published in the database for that waypoint, you're in luck.
That's a database hold. The MCDU fills in the course, the turn direction, everything.
But if it's not published, say you're holding at your present position, PPOS.
Then the FMS proposes what we call a computed hold. It just uses default values.
And this is where that pilot flexibility is absolutely critical.
It is. Because ATC might want you to hold on a 270 inbound course with right turns, but the FMS might suggest 090 with left turns.
And you can't just accept that. You have to modify the values.
Always. You have to make the airplane match the controller's instructions. Precisely.
Change the inbound course, the turn direction, and the leg definition. Is it time or distance?
That detail really matters. If ATC says 4-mile legs, you have to make sure the FMS isn't defaulting to a 1-minute leg. It's about airspace protection.
And actually inserting it is pretty straightforward, which is what you want under pressure.
You hit the LAT-RVT at the waypoint, or PPOS, select hold.
You verify, you customize the data, and then you press insert. Clean and simple. Okay, one of the biggest questions when you're told to hold is speed. Everyone asks, What speed will it fly? And, more importantly, will it break the rules?
It's a great question, and the answer shows how smart the FMGS really is. It calculates what it calls a predicted holding speed.
And it does that by choosing the lowest speed from 3 different options, right?
That's right. The first is maximum endurance speed, which is all about saving fuel.
Okay.
The second is the ICAO limit speed, to keep you inside the protected airspace.
And the third?
Any specific speed constraints that are already programmed at that waypoint, it takes the lowest of those 3.
And if there are no specific restrictions, the Airbus defaults to a speed based on green dot. Why green dot?
Well, green dot is the aerodynamic sweet spot. It's the speed for your best lift-to-drag ratio.
Which means?
It means maximal endurance. It's the most efficient speed to just stay in the air. You're maximizing your time for every pound of fuel you burn.
And in the A320, say with IAE engines, there are some specific buffers built in.
Right. It's generally green dot plus 20 knots below 20,000 feet or green dot plus 5 knots above 20,000 feet.
But this is where the crew expertise comes in. You can't just trust the FMS prediction blindly. You have to know the ICAO limits.
Absolutely. These are the numbers you just have to know cold. This is the non-negotiable memory item. It's the ceiling for any FMS calculation.
Okay, so lay it out for us. What are the limits we have to remember?
Up to 14,000 feet, the limit is 230 knots.
Okay.
Between 14,000 and 20,000 feet, it's 240 knots.
Right.
And above 20,000 feet, your max holding speed is 265 knots. The FMS will never propose a speed higher than that, no matter what your green dot is.
And we should quickly touch on timing again. You, as the pilot, have to confirm if ATC wants the hold defined by distance, like those 4-mile legs.
Or by time, which is usually 1 minute below 14,000 feet and 1.5 minutes above. A critical step when you build the HM.
Okay, here's where it gets really interesting for me. The geometry of the entry.
You
You don't get to choose how you enter the hold. The FMS picks for you.
It automatically selects one of 3 standard ICAO entries, and it's based purely on your heading relative to the inbound course.
It simplifies the job, but you still have to be watching that green line on the ND.
You have to know what it's trying to do.
So let's start with Sector 3, the direct entry. This is the big one, right?
Look, it's a massive 180-degree sector. You just fly to the fix and turn into the pattern. It's the easiest one.
The one we're all hoping for.
Of course, it's the most efficient.
Then you have Sector 1, the parallel entry. This covers a 110-degree sector.
Yeah, you're generally coming in from the opposite side of the hold. The aircraft flies parallel to the inbound course, but on the outbound side. Then it makes a turn toward the holding side to intercept.
Okay, and finally, Sector 2,
Yeah,
the teardrop.
the 70-degree sector. Here, the aircraft flies a 30-degree offset track into the protected area.
Before turning back to intercept the inbound leg, I always hear people talk about that 30-degree offset. Why is it so strict?
That is a fantastic point. That 30-degree offset isn't just a suggestion, it's a safety measure.
Okay.
The teardrop is designed to only go into the protected airspace for a very brief, very strategic moment. If you fly an offset that's too shallow, you could drift outside the safe holding area before you turn back in.
So the FMS is being that precise for a reason.
It's protecting you from terrain, from other traffic, from whatever is outside that defined block of airspace.
So the pro tip stands. If you are right on a boundary line between 2 sectors, the FMS might pick either one.
Don't sweat it. Just watch the green line on your ND. Trust the geometry.
All right, now we have to talk about a really critical nuance, one that can catch even experienced pilots.
Vertical management, specifically the VDEV logic when you're descending in a hold.
Yes, the Airbus trap.
It is a trap, and it's crucial to understand.
So why is VDEV the vertical deviation indicator on the PFD? Why is it so misleading here? Doesn't it just tell you if you're on path?
It does normally, but in a holding pattern, the FMGS assumes the hold is a flat circuit.
Flat circuit.
Yes, so it temporarily stops computing the descent path while it's circling. It's a simplification the system makes because it's prioritizing the complex lateral guidance of the hold.
So while it's turning, it's just thinking, I just need to get around this pattern sideways.
Precisely. And as a result, that VDEV needle you see on your PFD, it isn't showing your altitude error in the current circuit.
So what is it showing?
That VDEV calculation is actually based on the hold exit fix.
Wait. So the VDEV is telling me my error relative to a point I haven't even flown to yet.
Exactly. It's showing the difference between where you are now and where you should be to continue the descent after you leave the hold.
So if you blindly chase that needle in the hold,
You're going to be descending way too early or way too steeply based on a future position.
so the warning is crystal clear. Situational awareness over automation.
Absolutely. When you're in a hold, you rely on the next altitude constraint in the MCDU, or the altitude you have selected on the FCU. The aircraft will not go below those no matter what the VDEV needle is suggesting for the future.
Okay, finally, let's talk about getting out of the HM. Since it flies forever, you have to be the one to command the exit.
And your primary tool is the IMM XI2, or immediate exit command.
And the timing of when you press this is so important.
Critically important. It changes the behavior. If you press IMM exit before you even get to the holding fix, let's call that position 1,
Okay.
the aircraft will fly to the fix, but then just continue on the route. It never even enters the hold. It just aborts the procedure.
But if you press IMM exit when you're already inside the hold position 2 while you're circling,
Then the aircraft immediately turns direct to the fix and exits the pattern. It gets back on the route and resumes managed speed for that phase of flight.
and what if ATC changes their mind? Actually hold for another 10 minutes.
You've got the resume hold option. It cancels the exit command and just keeps you circling. Seamless.
And this brings us to what is, I think, the most valuable piece of data on the entire hold page.
The fuel prediction. This raises an important question about resource management and safety.
The crew has to be watching the last exit UTC fuel prediction.
Constantly. That number is non-negotiable. It's dynamically calculated using everything: speed, wind, temperature, your reserves.
And it tells you exactly when you must leave the hold to divert.
It ties this whole operational procedure right back to crew safety and critical decision-making.
So what does this all mean? The A320 FMGS is, well, it's incredibly sophisticated, but you have to know its rules and its traps.
Right. We've covered the 3 types of holds, the self-terminating ones, HF and HA.
And the one you manage, the indefinite HM.
We clarified the speed logic, how it defaults to that efficient green dot speed unless ICAO limits kick in.
And we highlighted the most dangerous trap, that VDEV reading, which is looking ahead to the exit fix, not your current position in the hold.
Demanding that you, the pilot, rely on your FCU and the constraints,
Holding in the A320 really is a seamless dance between pilot and machine.
but only when the pilot knows the steps. That knowledge of the underlying logic, it is absolutely non-negotiable for safety.
And efficiency.
Indeed. We know the FMS handles all the complex geometry of the entries, the speeds, the turns flawlessly. But let's just zoom out for a second on that last exit UTC fuel calculation we just talked about. Just think about the complexity for a moment. How many moving variables, your speed, altitude, the wind at every level, your fuel flow, the entire remaining flight plan. How many things must the FMGS constantly recalculate in real time?
To predict that single, final, non-negotiable moment.
Exactly.
It's a staggering amount of computing power. And it's not just dedicated to flying circles,
Right.
but to defining the precise moment when safety is on the line.
Something to mull over next time you're asked to extend the hold.
Thank you for diving deep with us into the intricacies of Airbus holding patterns. Until next time, safe flying.